Hello everyone, welcome to Dhaapps. This is the introductory Java course. Today we are going to learn about some of the features of the object-oriented programming statement in Java. So without wasting much time, let us plunge directly into the topic. So first of all, I would like to say that why we are studying this. So today's this particular session is gonna be more of the theoretical part because this will serve as a basis for the next two or three sessions, as we will be seeing the implementation of this particular lecture in the subsequent videos, and I also recommend to kindly do a thorough understanding research of this particular topic, although it might seem to be very boring or a theoretical one, but this is one of the most important sessions, as this will prove to be the most important part of the OOPS concept, that is the object oriented programming in Java, because till now we have not actually exploited the OOPS features that are already present in Java. So with this session, we start exploiting the various features and get our hands dirty with the object-oriented programming structure of Java. So first of all, why use this object-oriented programming structure? See, there are programming languages like basic, there is this QBasic or this assembly language, where we don't really get to use this object oriented programming statement. So what happens in object oriented programming statement is that we get the opportunity to make very clean, precise and compact codes for a particular job. Why? Because using OOPS, we can reuse a particular sector of code that has already been used. We can call this particular code segment from another program and use it over here, and we can also enhance security in some cases. So now we'll be seeing the various OOPS features that we have on board in Java already. So the first one, which we would like to see, is class. The class, we have seen the use of the keyword class in any Java code for that matter. But what is class actually? See, when we are speaking of car, or when we are speaking of a bird, let's take the example of car for that matter. So for making a car, we need some particular features, right? Like we need to we need to have the windshield, we need to have the tire, and we need to have the tire, and we need to actually have certain features for that particular car to function properly. So that particular code, or that particular, I would like to say, template, which any car should have, can be thought of as a class. A class can also be thought of as an object factory. Now, to understand class, we'll come into the next concept, that is object. Now, what is an object? Now, when we are speaking about a car, and I suppose I tell you to bring a car in front of me, we are not actually bringing a car in front of, no one can bring a car in front of me actually. What people bring actually, when I speak of car, there are various cars out there in the market, right? We can speak of Maruti 800, also we can speak of uh, Ford, maybe for that matter, or Hyundai or Honda. There are multiple cars level out in the market, but mind you, these are only instances of cars. That is the same, that tire, that windshield, that ignition mode, the steering, seats, everything is same everywhere. Everything is same everywhere. But the only difference is a change in the features. That is, suppose in Maruti 800 we have got no airbags. That is, number of airbags is equal to zero. But in in Ford or in Hyundai or in Honda, we have got maybe four in some, maybe six in some. So these small changes are those which make an object. And for making this object, we need to call a class. So by changing this particular some features of a class, we can create a separate object. And this is the object that we will be calling every time in our code. So now I guess everyone can understand that why class is called an object factory. More on this can be found out when we will be doing the coding part of this particular session. Next comes the concept of abstraction. This one, abstraction. Now, for making you people understand what is abstraction, first I would like to take the example of a switchboard. See, there is a particular circuit which needs to be completed or which needs to be broken for maybe a light to glow or maybe a fan to start in the room. So all these are controlled by that switchboard only. Now the thing is that we are just pressing the switch of the particular switchboard and the fan starts rotating maybe. Now we are not at all interested in what is the circuit that is happening inside or what are the various attributes or what are the various changes that are happening in the electric current at that particular point of time. So this is called abstraction. Now if for some reason this fan is not rotating, then I'm not interested about what is happening behind the scenes, what is happening inside the keyboard. That is not my job. I'm only concerned about I'm pressing the switch and whether the fan is on or off. Whether the fan is doing the necessary changes. If that is not happening, that means the fan is faulty. So that needs to be changed or repaired as the case may be. So we are only interested about those particular parts. That is the important parts of that particular code. And we are not interested at all in the internal details of how the things are happening and all such things. So Java supports abstraction, and we'll find the example in the coding part again. Now comes the concept of polymorphism. Now, what is polymorphism? So, poly means many and morph means form. So, anything which takes many forms is known as polymorphism. So, here I would just like to request everyone to kindly keep a small tip or a small note over here. That is, function overloading is an example of polymorphism. We'll come to the details of what is function overloading and all such other concepts when we will go further into the coding part of this code again, of this particular session again. What is polymorphism in daily life? Like suppose suppose a human being. So a human being, when person is when the person is in a supermarket, that person is just a customer, will act like a customer. When that person is in school, then that person will act as a student. When that person is in the university, that person might act uh, as a university professor, if that case is. Again, when that person comes back to home, that person may be a housewife or just a child of the family or something like that, or a daughter or something like that. So this one, the person is same, just the function that that person does everywhere is different. Like one cannot act like a university professor inside a supermarket, right? And at the same time, one cannot act like a customer in a university, right? So the same person is doing different types of roles as the case may be, as the case demands actually. So that is what is basically the example of polymorphs. Next comes the concept of inheritance. So inheritance is a concept in which people actually take the attributes or traits of their ancestors or their parents. Like we find often when we see maybe a baby, or we often say that the ear is like that baby's mother, the nose is like that baby's father. So this is what is inheritance. The one example of inheritance, that is, we are taking the attributes and features of our previous generations and we are putting it here, and we are making some small changes and we are making something new. That is an example of inheritance. Next comes the concept of encapsulation. Next comes the concept of encapsulation. So what is encapsulation? So here we can find this word capsule over here. So there's this medicine capsule. So in capsule, all the contents of that particular capsule is all morphed or all merged into one single unit, that is that capsule. So when we are taking that capsule or when we are consuming that capsule, we are getting all the constituents of that particular medicine in one unit. So the wrapping up of the class and the data, wrapping up of the functions that operate on the data and the data in a single unit called class is known as encapsulation. So we will find so in the next session we will get to know about how Java is all about encapsulation actually. Okay. So this was basically the theory of today's session. If someone has not understood, I request once again to kindly go again and replay this particular video, or maybe go online and search for the various definitions of these, so as to make this part at least clear, because this will serve as the base for the next 2 or 3 lectures that are coming. So that was all for today. Thank you and have a nice day.